Welcome back to Chemistry Laboratory, Kebri Dehar University, Somali region, Ethiopia. This is Dr. Rajshekhar Medidi, Associate Professor in Chemistry. So today we would like to discuss a very important experiment in titrimetry, that is standardization of sodium hydroxide. So let us see the procedure now. How to standardize sodium hydroxide? Sodium hydroxide is a base actually. We need to standardize by using an acid. Mainly we can use hydrochloric acid. So this is the most basic experiment in titrimetry, very important also. Let us see the procedure. That is, objective is or aim is to determine the strength of sodium hydroxide by using the standard solution of hydrochloric acid. So the reaction, the type of reaction it is, what type of reaction means? It is an acid-base titration because sodium hydroxide is a base and hydrochloric acid is an acid. So if we see the procedure here, before that the reaction between them. So here the procedure is maybe classified into two different types, part 1 and part 2. The part 1 it says that we have to standardize the hydrochloric acid by using standard solution of sodium carbonate. And the part 2 will be the estimation of sodium hydroxide by using the standard solution of hydrochloric acid. Two parts are very important. So we have to go systematically. In part 1 reaction we can see we are standardizing the sodium hydroxide by using standard solution of hydrochloric acid. So here we can see the formality, like apparatus means we can use the burette, normally pipette, conical flask, beakers, wash bottle, magnetic stirrers, etc. can be used as apparatus. So in acid-base titrations or in any titrimetric reactions, the apparatus will be the same. It will be common for all. So that is about the apparatus. Coming to the chemicals required, the chemicals that are required in this reaction, in this titration, in this experiment, we can see that sodium hydroxide is a base, secondary base, and hydrochloric acid is a secondary acid, and sodium carbonate is a primary base. So these three chemicals are used. That is about the chemicals. And the indicators. So we can use two different types of indicators here. Phenolphthalein can be also used as indicator, and also methyl orange can be also used as indicator. So if we see the phenolphthalein, we can see the phenolphthalein endpoint will be from pink color to colorless. That is, phenolphthalein will gives the pink color in the basic medium, and in the acid medium it converts into the colorless. But whereas the methyl orange indicator, it gives the yellow color in the basic medium and confirms the pale pink color in the acid medium. So any one indicator may be used in this titration. Okay, in this first part 1 we will use methyl orange as an indicator. Okay, right. So now the part 1, that is the standardization of hydrochloric acid by using standard solution of sodium carbonate. So here the part 1 it says that if you want to find out the question is standardization of sodium hydroxide. So the part 1 it says that if you want to find out the strength of the sodium hydroxide, we must know the strength of hydrochloric acid. Without knowing the strength of hydrochloric acid, it is impossible to find out the strength of sodium hydroxide. So that is why first we need to standardize the hydrochloric acid by using another base, that is called as sodium carbonate. Here the hydrochloric acid is a secondary standard and the sodium carbonate is the primary standard. By using this primary standard, we can find out the strength of hydrochloric acid in part 1. And after that, after getting the strength of hydrochloric acid, we have to estimate the strength of sodium hydroxide by using the standard solution of hydrochloric acid, which is obtained in the part 1. That is the procedure, logic we can say, right? So in this part 1, standardization of hydrochloric acid by using sodium carbonate as the base, having the strength of 0.1 normal, which is already concentrated one, which is already found out, which is already measured before. Right. So here the procedure is, in the part 1, we have to pipette out 10 ml of sodium carbonate of 0.1 normal into the conical flask, and then to that solution you should add 30 ml of distilled water to make it volume increase, to get the visuality clarity of endpoint. And then we need to add 2 drops of methyl orange indicator. As I told you, methyl orange indicator, when it is added in the basic medium, it appears yellow color. So after that, take the burette, fill the burette with the acid solution of hydrochloric acid up to the mark. which is not known, strength is not known, but sodium carbonate is known already, right? After performing the titration, so after getting the, when you are adding the hydrochloric acid into the conical flask containing sodium carbonate, suddenly endpoint appears, reaction completes. It forms the yellow color converts into the pale pink color. That's it, the endpoint. For example, if you got the endpoint value, the titer value is around 10 ml, then we can report that in the table that is provided on the board. You can see the board. So this is about the procedure for part 1. After getting the value here, so let us see the table 1 here. So volume of sodium carbonate taken, and also the burette readings, initial and final, and volume of hydrochloric acid run down. Actually, in this titrimetric analysis, we have to perform 3 different types of titrations, same titrations 3 times, so that at least 2 readings must be in coincide with each other. For example, if we have done the titration 3 times, suppose the values what we got is, initial value is 0 without starting the reaction, and the reaction completes at 10 ml, for example, first titration. And the second titration, initial value will become the 10 ml actually, and then it goes up to 11 ml. Suppose it is 11 ml, second titration. And the third titration is, initial value will be the 21 ml will be the initial value. And if you got 10 ml again, so 3 values will be reported. So from these 3 values, we have to check which values are concurrent, consecutive. So the first value and the third value is concurrent, consecutive. So we can take the 10 ml as the final value. That is 10 ml of hydrochloric acid is used to consumed with sodium carbonate to convert that base into neutral. That is the reaction. So here, let us incorporate the values here. There is a law of equivalence formula, N1V1 is equals to N2V2, where we can represent that as, suppose if we have taken N1V1 as sodium carbonate and N2V2 as hydrochloric acid, we can see the representation here. N1 is equals to normal of sodium carbonate, that is 0.1 normal, that is already known, and V1 is equals to volume of sodium carbonate, that is 10 ml we have taken, and N2 is equals to normality of hydrochloric acid, that is unknown, where we have to find out, and V2 is equals to volume of hydrochloric acid, that is 10 ml we got from the burette reading. So incorporate these values, you will be getting the formula that will be for finding of normality of hydrochloric acid. N2 is equals to the formula N1V1 is equals to N1V1 by V2. So we can get the value 0.1 normal of hydrochloric acid. So in the part 1, from this titration we will be understood that from these values and the calculation, the strength of hydrochloric acid is 0.1 normal. That is completed. Now in part 2, by taking the standard value of hydrochloric acid as 0.1 normal, we have to find out or estimate the amount of or the strength of sodium hydroxide in part 2. That is the part 2. Let us see now in part 2 the procedure. So in the part 1 we have seen simply the reaction, sodium carbonate reacts with 2 moles of hydrochloric acid forming the 2 moles of salt, and water and carbon dioxide is formed. That is a simple reaction. The reaction between the acid and base will be always results in the production of salts. So here coming to the second part, that is part 2, we will see the procedure, same procedure, but here instead of sodium carbonate we will use sodium hydroxide. So pipette out 10 ml of sodium hydroxide into the conical flask, because part 2, and add 30 ml of distilled water to increase the volume. Now again in this part 2 you can add phenolphthalein indicator, that gives the good result. Phenolphthalein indicator 2 drops is added, because it is phenolphthalein indicator, as we have discussed already, it gives the pink color in basic medium. So after adding phenolphthalein indicator, the pink color, then titrate with the hydrochloric acid taken in the burette, which is already known of 0.1 normal from this calculation of part 1. Then perform the titration, and at the end point the color changes. Phenolphthalein will be converting, as you see here, it will be formed from pink color to the colorless solution. That is end point. So from these values, suppose if we got in part 2, suppose if we got the values, again we have to keep the same table 2 here, and perform the titrations for 3 times. So the table 2 will be the volume of sodium hydroxide taken will be 10 ml, and burette readings will be there, and volume of hydrochloric acid consumed will be there. And from these titrations, if we perform 3 titrations, from that suppose the result is, first one is 9 ml for example, second one will be also 9 ml for example, and the third one is 10 ml. As I told you before, we have to take 2 consecutive values which is same. Now we can confirm the value 9 ml as a titer value of hydrochloric acid in part 2. Now after performing the calculations, we have to find out here normality of sodium hydroxide, that is estimation of sodium hydroxide. The formula says that here N1 is equals to, that is we can say N2V2 by V1, or we can take N3V3 N4V4 also for our understanding. So from this, after incorporating these values, that will be 0.1 into 9 by 10, that gives 0.09 normal value. That means the strength of sodium hydroxide from this part 2 is 0.09 normal. So this is the procedure to perform the part 1 and part 2. Very simple reaction and very interesting also. You should understand how the part 1 and part 2 has been done. So this is about the theoretical part of experiment. Now we are going to perform the experiment visually, physically and practically. Let's perform the experiment and come back for the second video, how we can incorporate these values. Okay, thank you. You can note down the procedure.